Okay, so instead of doing 29, let's do a different one. Maybe do this one here, number 30. You guys see that, everyone?
Yes.
Okay, so Shania is asking about 29. Instead, I'll do 30, and I'll let you do the 29 later. So let me open the board. So the question is to basically simplify. Okay, assume all the variables are positive. So we just need to simplify this. For example, if you look at number, let's say number 6. To simplify this, the square root of 25 is, the square root of 25 is
5.
5 minus the square root of 81 is
9.
9. So 5 minus 9 is -4, right? This one is kind of similar, but a little more complex. So let's do that. Okay, 29, I mean 30. So let me open the board and take this one. So it'll be 8.4. And the question is 30. So simplify. So 9. So pay attention here to the radicals. They're not that complex. So 27 p squared minus 14 radical 108 p squared. Okay, so we start with the number. Do we know the square root of 27? We don't. 27. We do know the square root of 25, but 27 unfortunately doesn't have a perfect square. So we're going to turn 27 into two numbers. Maybe one of them it has a perfect square. So give me two numbers that multiply to 27. One of which.
9 and 3.
That's right. So we have 9. We're going to take this 27 and p by itself, p squared. Okay, so 27, we're going to turn that into 9 and
3.
9 and 3. That's right. The reason we did that because we don't know the square root of 27. If it was 25, for example, we would just say 5. But unfortunately, this is not 25. It's imperfect, so we're going to split it into two numbers. One of them is a perfect square. So which one has a perfect square among these?
9.
The 9, that's right. And then we split this radical into two radicals, p by itself, p to the second, and this one here. Let's continue here. So this will be 9 multiply radical 9. What is radical 9? Will be 3. That's right. And radical 3. So we split this again into two. Radical 3 stays inside, and radical 9 turns into 3. Then this one, the radical and 2 cancel out. Just p squared outside. Okay, so if we have a second power, we have the square root. The second power cancels against the radical. You end up with p only. For example, if you have any number x and you have, I don't know, you have, let's say you have b here and you have b. Okay, you can cancel that radical and the power, you have x left. Here, you have 2, and the square root means 2 here. The index is 2. Cancel that against that, you have this. So again, if you have the same number, the x, the radical and the power cancel out, you end up with x by itself. Okay, so now we can multiply these two. So we have 9 or 27. We can bring this p to the front. And radical 3 here. Okay, minus 14 for this one. We're going to do the same thing. We're going to split this into two numbers. So negative 14. First, we're going to write 108 by itself. Do we know the square root of 108?
No.
We don't. Okay, if you put this in the calculator, you will give it a decimal. Okay, 108 doesn't have a perfect radical. So if it doesn't have a radical, perfect radical, what do we do with 108?
Split it.
That's right, we're going to split this into two numbers. So give me two numbers, so multiply to 108. One of them might be a perfect radical. So what happens again to this 2 and the radical? The square root means we have a 2 here and 2. What happens to the 2 and the radical?
Cancel each other out.
That's right, this cancel. So we have p by itself left, outside the radical. And what numbers multiply to 108?
36 and
3.
36 and 3. Very good. Now, which one has a perfect radical?
36.
That's right. What is the square root of 36?
6.
That's right, it'll be 6. And the radical 3 stays inside because radical 3 is not perfect, it's a decimal, it's 1 point something. Bring the p down here, or we can move it to the front. We're going to move it in the next step. So 27 p radical 3 minus, what is 14 times 6? 14 times 6.
84.
And that's right. So I'm going to write 84 here. The radical 3 is still inside. We can move the p to the front here. And that's it. Now we have the same radical here, the same radical here. We can combine those together, just like if you have, for example, 5 radical 7 plus 2 radical 7. What is this equal to? 5 of something plus 2 of the same thing. The total is?
7, root 7.
That's right, we're going to add this and 2 together, 9, radical 7. Same thing here, so we have the same radical. So we're going to combine, so 27p minus 84p of the same thing, which is radical 3. Just like here, so here you do 5 plus 2, in parentheses, radical 7. That's how you get the 9. This should be 7, not 9. Okay, so 5 and 2 together, in parentheses, radical 7. 5 and 2, that's 7. So you end up with 7 radical 7. That's what we did here. Since it's the same radical, we just need to combine these, 27p minus 84p plus 27p minus 84p.
Negative 57.
57. You sure about that?
Yeah.
Okay, good. So that's basically how you simplify those radicals. So it's 57, and don't forget the p. Forgot the p here. It's gotta be 57 and p. The p here. Okay, so some radicals are not perfect, unlike 25. 27 is not perfect, so we turn that 27 into 9 and 3. Why? Because 9 has a perfect square. That's 3. The radical 3 stays inside the radical here. Same thing here, 14 down, 108. It's not a perfect radical. If you put that in the calculator, it's not perfect. That's what we turn it into. So you look for the best combination. There might be other numbers that multiply to 108. It could be other, for example, 2 and, what was it, 254, right? You times 254, you also get 108, but 254, none of them has a perfect square. So you want to find the best combination. 36 times 3, so 36 turns into 6. The 3 stays inside the radical here, p. you move p to the front. If you end up with the same radical, then you can combine them, just like 5 radical 7 plus 2 radical 7. Combine those, and you get here. Okay, so that's how radicals work. If you can't find it right away, you can split the number and into numbers that might have a perfect radical.